and how he used to build a security system, keep track of where his parents were in his house when he was 11. Um, Simon has a background in genetics, loves mathematics, very wide range of interest, it sounds like. So this talk, I think, is going to be very, very interesting for all of us. So with that, Simon, I won't take any more time. I'll turn it over to you. Can't wait to see what you've got to share with us.
Okay, thank you very much. Can you see my screen, by the way? It should say from here to there and back again. Can you see that? If not, let me share it again. Yes, you can. Good. Oh, do shout out, by the way. And likewise, I know we've got chat, so if people have questions as we go along, please throw them into chat. I'm happy to be interrupted. Come on screen, switch your camera on, whatever. I'll try and keep an eye over here. I've got far too much to present now. I always do, and we shall see how we go along. So from here to there and back again. Let me just click over here, get started. I'm going to talk about mapping, mostly because I like talking about mapping. I have a thing about maps. So I'm going to talk about the origin story, how I got into the space of mapping. I'm going to talk about what a map is and what a map isn't. Then I'm going to talk about patterns with maps. After which we'll get on to discussing the issue of change. So how you use those patterns to determine change going on within a system. Then we're going to talk about AI, because you can't have a conversation today without mentioning AI. So we'll talk a little bit about that. Then I'm going to talk about the changes going on to the coding, and that'll bring me into a field known as rewilding software engineering. It's not a field, a subject. Then I'm going to talk about decision-making processes, mostly because that fits back into software engineering, what engineering actually is, and architecture. And then finally, if we get a little bit of time at the end, I want to talk about some sovereignty issues, mostly because when I map, I do mapping at nation state level, all the way down to companies, all the way down to individuals, and of course individual projects in between that. There's a couple of sovereignty issues which sort of connect these themes together. So that's roughly the journey we're going to go along, and we're going to try and do this in an hour. And I must keep an eye on the time. Do shout at me if I'm getting close. All right, so let's start with the origin story. The origin story for me starts with this company, Fotango, online photo service. Had about 16 different lines of business. It was quite profitable. In total, across all those different lines of business, it had about, must be between 5 to 10 million users, roughly in that sort of mark. This is back in 2005. So it was profitable, but it had a problem. And the problem was this person, the CEO. The fat cat in charge of our company had no idea what they were doing. They were completely and utterly clueless. Now, I know this for a fact because I was the CEO. So I used to come up with these wonderful visions and statements of the future, things like our strategy is customer focused. We will lead an innovative effort of the market through our use of agile techniques and open source. A friend of mine's a chap called Kent Beck. He produced something called a book, Extreme Programming. We'd been very heavy adopters of XP back in, must have been late 1999, slightly before the Agile Manifesto came out. And we were also big users of open source. But this strategy was basically, I pinched it from another company and changed a few words. I mean, this was the level of my thinking back in 2004. So I ended up going into a bookshop in Charing Cross because I started to get worried that people would rumble, that I had no idea what I was doing, despite the success. And so I was in this bookshop because I'd read every book I could find on strategy, and it made no sense to me whatsoever. And the bookseller asked me, had I ever read Sun Tzu's The Art of War, to which I hadn't. So she persuaded me to buy 2 different versions of the book because they're all translations. And I'm really grateful for this, because it was in the reading of the second one I noticed a particular pattern. So Sun Tzu talked about 5 factors that matters in competition. Oh, sorry, bless you. The first one was that the first factor that matters in competition is have a purpose, a moral imperative to do something. The second factor that matters is understand your landscape, the environment you're competing in. The next factor was understand the climatic patterns or the heavens, the weather, so how that landscape is actually changing. Then you need to understand doctrine, principles of how you organize yourself. And then finally, you get into leadership and gameplay. So there's this wonderful cycle in this book. Have a purpose, understand the landscape, understand how that landscape is changing, orientate yourself around the space with how you organize with your principles, and then you can decide where to attack and then you act. I love this. And at the same time, I came across the work of John Boyd, the Mad Major. And if you don't know who John Boyd is, he created something called the OODA loop. He's a US Air Force or former US Air Force pilot. And the OODA loop very simply says, one, observe the environment. That's what landscape and climatic patterns are about. Observe the space you're in. Then orientate yourself around the space. That's what principles, your doctrine are about. Then decide where you're going to act, and then act. And then you observe the environment again. And I love this. These two nicely sort of overlapped. I'm taking a lot of liberties here with, particularly with OODA, but it was they nicely seem to meld. And this got me really fascinated by the question of how do I observe the landscape I'm in? And that's what got me into maps. So I started reading everything I could find on maps, military history of maps. And this is one of my favorite battles, which is the Battle of Thermopylae. So in military history, we've used maps to learn from one battle to another. And Themistocles was an ancient politician, Greek general, had a problem. The Persians were invading. Now, he had choices. He could defend around Athens, defend around Thebes. What he decided to do was to block off the Straits of Artemisium, force the Persians along a coastal road into a narrow pass where a smaller number of troops could defend against a larger force. Now, Thermopylae means hot gates. That's literally what it means. And as it's a narrow pass, it acts as a force multiplier. So I was fascinated by this because I could see that we could talk about resources and what our competitor is going to do, and we could have a discussion about the way to defend or to attack, and we could learn from this. And so I started looking at how I was organizing things in my company. And at that time, this must have been 2004, I love something called SWOT diagrams. I used to use them all over the place. Now, SWOT diagram stands for strengths, weaknesses, opportunities, and threats. So what I've done is I've created one for this battle. So strengths, a well-trained Spartan army, a high level of motivation not to become a Persian slave. Weaknesses, the E4s might stop the Spartans turning up. A truckload of Persians are turning up. Opportunities, get rid of the Persians, get rid of the Spartans. We're Athenian. We actually hate the Spartans. Threats, the Persians get rid of us. The Oracle says a really dodgy film might be produced in a few thousand years' time. And I simply put those next to each other and ask that question, what would you use to communicate and determine strategy in battle? A magic framework or a position and movement described by some sort of map? And what I realized is I was using this magic framework and I wasn't looking at the map. And so that made me then turn around to the rest of the organization and ask people, send me all your maps. And I got loads of them. I got customer journey maps, I got mind maps, I got systems maps, I got business process maps, loads of maps. I was like really excited by this. And so I took one of these maps. This is a systems map for one service, the online photo service. And I looked at one component. In this case, I put it in gray, a customer relationship management system. And I simply moved it across the map. Now that's so exciting. I'm going to do that again. I think I'll do it again as well. It's just like very exciting. And I asked myself, how has that changed? And the answer is, it hasn't. Now, this got me confused because I knew if I took a geographical map and I moved, I don't know, Australia and put it next to UK, that map has changed. So why hasn't it changed here? And it took me ages to realize that, but one thing all these maps have in common is they're not maps. None of them are. They're all graphs. So it's worth explaining the difference. And the three images at the top are all graphs, and they're all identical graphs. 3 locations in the UK, Nottingham, London, Dover, connected by 2 roads, the M1, M2. Now, the 3 images underneath them are all completely different, and they're all maps. Again, 3 locations, Nottingham, London, Dover, connected by 2 roads, the M1, M2. So the difference between a graph and a map, well, you go, well, it's got a compass. Well, that compass does something special. That compass gives space meaning. So the difference between a map and a graph is that in a map, the space has meaning. In the graph, it's just the nodes and the connections between the nodes. Now, in order to give space meaning, you need 3 basic things. You need an anchor, such as magnetic north. You need the position of pieces. This is north, south, east, or west of this. And you need consistency of movement. So if I'm going north, I'm going north. If I'm going south, I'm going south. If you've got all of those, you can map a space, you can give space meaning, and what you have is a map, not a graph. So I thought, well, how do I take the system's graph and turn it into a map? Gosh, that's a tough question. So I started off by thinking, well, I needed an anchor. So I would anchor around the users. So the users could be the business, it could be consumers, it could be regulators. In this case, I've got business and consumers. I'm going to use just the graph. So I'll put those at the top of my map. Okay, now I need position. Well, how do I do that? Well, the business has needs. It had a need for a website, subscription models, people paying for that. It had a need for prints. It had a need to sell online photo storage. And consumers wanted to do image manipulation, online photo storage, and prints. So what we've got is a business and consumer at the top connected by a set of needs. Now, all of those needs themselves had needs. There were underlying components. So in the case of the website, there's CRM, compute, all the way down to power. And the further we go down that chain, the less visible those needs become. So to the consumer, they could visibly see the online photo storage, the prints, the power used to power the data center. I mean, that's very, very distant, far removed from them, still essential for the operation of the whole thing, but it's far removed. So now I've got this concept of anchor and position, but I'm still missing movement. So it turned out all of these components were forms of capital. To actually demonstrate this took me 9 months, 9,223 publications, 9 months of about 60 to 70 hours a week. I won't go through the story. But it turns out that all of these components are evolving forms of capital, and they start off with the genesis of novel and new items, custom-built examples, products and rental services, commodity and utility services. So if I simply just ask the question, how evolved is this component, position it, then I've got anchor, position, and movement, and that is a map. And that's the first map that I produced back in 2005. Now, you'll often see me doing this with an example, with a cup of tea or something along those lines. The point about this map is I can look at it and I can ask questions. I can challenge how we've positioned things. Anyway, so what? Why does this matter? Let me show you an example. This is an insurance company. This is about 2010, 2011. This is a process flow. They need compute, they order server goes into goods in, they modify, mount, and rack it. They had a bottleneck with the modification mounting of servers. So they came up with a plan. The entire group of them looked into this problem, spent about five to 6 months working on the problem, came up with a plan of investing in robotics in order to automate this process of modification and mounting of servers. Now, return on investment calculation sub 1 year. They got the entire business case done. I was asked to have a look at this problem. Now, I can't turn up and ask the question, why are you using robots or wanting to use robots, because they've built the entire business case. Most organizations that we faced don't have maps. They're run by narrative stories. And the problem with stories is that we tell people that great leaders are great storytellers. So if you challenge somebody's story, you challenge their ability for leadership, which is why people get defensive. So here they are, they've got their whole story, their whole business case and everything else. If I turn up and say, why are you doing robotics? They go, who are you? You know nothing. So I said, could we map this? We had about an argument for 15 minutes, and then we spent 15 minutes mapping it. And so that's the map we produced. It's 2010. User needs compute, order server goods in, rack, mount, modify. Now, one of the beauties about a map is I can challenge the map without challenging the person. So I'm not challenging their story. So they put compute in product. I might go 2010. Surely that's more of a commodity utility. They've got servers in commodity utility. Okay. I was looking at that. It didn't take me long. I simply asked the question, why have you got racking custom built? Well, it turns out they had custom built racks. So then I asked, what are the modifications you're making to servers? Well, the servers don't fit our racks, so we have to take cases off, drill new holes, add new plates in order to get them to fit our racks. And that's why you need robotics. Yes. It didn't take long for somebody in the room to go, why aren't we using standard racks? Now, these people aren't daft. They were simply trapped by past story. At some point, there wasn't such a thing as standard racks. And so what they've been doing is optimizing process flow without considering the fact that everything evolves. So they've been going like compute, order, service, serve. Let's make this process flow more efficient without ever considering everything evolves. And of course, once we'd overcome this, it wasn't long before we were able to overcome compute as a utility, and they realized that actually doing robotics in data centers made no sense whatsoever. Either use standard racks or you go and use cloud services. It was that simple. Now, one of the things, I'm going to do a bunch of maps which deal with cultural issues and also practices. I'm just going to change the labels at the bottom. What we actually have on a map are 4 different stages called phase 1, 2, 3, 4. There's a set of different labels that we can use depending upon if we're dealing with practices or data or knowledge or ethical values. What I'm going to do is I'm going to combine a set of them. So I'm going to use Genesis, custom emerging, they have the same meaning, product converging, it has the same meaning, commodity accepted. All right, let's talk about patterns. One of the things I use maps for is pre-mortem challenge and post-mortem learning. So before I start a project, we map it out, and that's where we do the challenge bit, stop us custom building racks or whatever. And then we go and build the projects, and afterwards we come back and use the same map to do post-mortem learning. So we look at what patterns we learned from the map. And if I go back to the strategy cycle, there are 3 basic forms of patterns that you see. There are the climatic patterns, the rules of the game. There's about 30 of those. They're the principles by which you organize. There's about 40 of those. And there's the stratagems gameplay, and there's about 150 of those. So the climatic patterns, the rules of the game, happen regardless of what you do, if there is supply and demand competition, and they're useful for anticipation. The principles are universally useful. So it's a good idea to do them. You don't have to, though. You've got choice. There's about 40, as I said, and the stratagems are all context specific. So if you don't use them in the right context, they can actually be harmful. All right, so let's quickly show some examples. Let's deal with principles. And I've been sneaky. I've hidden a few as we've gone through this presentation. The first principle you learn is know your users. Sounds ridiculously simple. It's unbelievable. Even today in 2025, I go into organizations who don't know their users, their user needs. back in 2005, this was obvious, but I still see it today. So principle number one, know your users, focus on the user needs. Really simple. The next thing is know the details, know the supply chain. Again, most organizations I see today, even today, they know what we call one up, one down, who we sell to, who we buy from. They don't actually understand their supply chain at all. The third one is understand what is being considered. There's a world of difference between, say, a custom-built rack and a standard rack. So it's not enough just to graph out. You've got to actually map it out as well to really understand the context of what we're dealing with. All right, let's show you another pattern. And this one, I'm going to go to a heavy engineering project. This is HS2 high-speed rail. This is James Finley, CIO of HS2, or former CIO. He had a problem in 2012, which is they needed to build this entire railway in a virtual world. And the reason why they needed to build it in a virtual world is it's easier or cheaper to dig up a virtual world and go, whoops, we've got that wrong, than the English countryside. So they needed to build this whole railway in a virtual world. And this is the systems graph for doing that. Now, back in those days, and this was about 2012, the way we used to manage projects in government was fairly simple. We used to break them down into, group together common components, like a bounded context, and then we'd outsource them in lot structures. So we'd go like lot one engineering, lot two, user experience, lot three back office, outsource them to different providers, and then we'd have massive cost overruns and failures. James wanted to do something different. So what he did was he took this systems diagram. He's an old friend. I taught him to map, and he mapped it out. And then he sent that map to me and said, how do you manage something like this? Now, this was easy for me. I'd been mapping since 2005. I'd made the mistake of using extreme programming everywhere. And of course, within a couple of years, I'd learnt, we hadn't, it doesn't work everywhere. I couldn't explain why until I had maps. As soon as I had maps, it was easy to explain. So if you look at this map, all of these components are evolving. They're evolving from this uncharted space on the left to the industrialized on the right. If there's supply and demand competition, everything evolves. So we're going from, everything, money, penicillin, all starts on the left. Unexplored, unknown, undefined, eventually becomes industrialized. Straightforward. Okay. Because of that, there's no such thing as one-size-fits-all methods. It doesn't matter whether we're talking about project management or purchasing or financing, anything. So on the left-hand side, it was good to use things like extreme programming, because extreme programming was good at reducing the cost of change, and change is the norm. If you're in the uncharted space, it's constantly going to be learning about new stuff. Eventually, it ends up on the right. So on the right, you want to focus on reducing deviation. You don't want change. You want everything the same. It's a commodity. So techniques from Six Sigma are really good here, or outsourcing. Now, in the middle, between these two, you want to be reducing waste and learning. So things like, Scrum and all that stuff like MVP really plays out well there. So we simply applied that to a map. And this is what I'd done beforehand. So it was easy to show James how to do that. So the left-hand side, we built in-house with Agile techniques. The stuff in the middle, use off-the-shelf products, use something like Lean. Stuff on the right-hand side, outsource to utility suppliers, use something like Six Sigma. And of course, now we can have a discussion about what methods to do. All right. So the simpler thing you learn is you use appropriate methods, whether it's finance, purchasing, marketing, whatever it happens to be. Of course, that doesn't go down well at an Agile conference when you tell everybody that Agile doesn't work well everywhere, any more than it does at a Six Sigma conference or a Lean conference. But the point is they each have their appropriate context. And so that's exactly what James did, and that project ended up in front of the Public Accounts Committee. It was delivered way ahead of schedule, way under budget. Now let me show you what normally goes wrong. Let's take our systems graph. Let's take one of those lots, engineering. Let's just, we're outsourcing it. All it looks sensible because it's like all engineering stuff. Let's overlay that on the map. I can tell from the map that the contract's going to fail before we've even signed the paperwork. The reason it's going to fail is the stuff on the right can be specified and the stuff on the left can't be specified because it's constantly changing. And so what we've done is bundle that into one contract. So we've almost guaranteed cost overruns and failures. And the thing is, you'll get into a fight with the vendor, and the vendor will say, "Oh, look, we delivered the stuff on the right-hand side. And the problem was all the stuff on the left-hand side." Well, except for you're not talking in left and right terms. They'll just say, "Oh, the land registry, you kept on changing your mind." But you had no chance of ever knowing what you actually wanted in that space. The problem was actually specifying it in a contract. Anyway, this sort of stuff we did in UK government, one project alone, we saved about 425 million simply by mapping it out and challenging what we're doing, about 1.5 billion in its lifetime. We saved billions across government. I've got to say, I've been horrified by the US and Doggy, the Department of Government. Not that the concept of trying to make efficiency, but the manner in which they've done it is so flawed and so wrong. I mean, it's been pretty depressing to watch, actually. But yes, we saved billions across government. We mostly did it by, well, we didn't have to get rid of civil servants. It was mostly by getting rid of external consultancy firms, getting people to think about what they're actually building. All right, so that's doctrine. Then there's a whole bunch of patterns, climactic patterns, which are sort of rules of the game, and they're useful for understanding change. So let's go through some of those. So this is roughly where we were in 2005. User needs an application built on best coding practice on a runtime, operating system, best architectural practice for compute as a product. Well, the first pattern you learn, I've already explained to you, is everything evolves. So we knew that compute was going to become a utility. Back in 2005, I thought it was going to be Google. I didn't realize it was going to be Amazon. A friend of mine, Ben Black, was actually working at Amazon. He made the proposal for EC2. It was Chris Pinkham and others who built it as a standalone service in South Africa. Another friend of mine, Jesse Robbins, was the master of disaster for Amazon's data centers. Wouldn't allow this EC2 nonsense near their data centers. It was actually set up as a standalone service. You'll often hear people talk about, oh, it was all about sharing. It wasn't. It was built as a standalone service. All right. The first thing you learn is everything evolves. The second pattern you learn is that past success breeds inertia. So, if we had lots of best architectural practice for compute as a product, we'd have inertia to this change. The classic example of that is Netflix versus Blockbuster. So first with a video, or first with a website, Blockbuster. First with a video ordering online, Blockbuster. First with video streaming experiments, Blockbuster. First to go bankrupt, Blockbuster. Blockbuster out-innovated everyone. Their problem was inertia created by their business model, which was late fees, which depended upon having a physical store. Netflix was a DVD mail order company, so it didn't have that problem. All right. The next pattern you learn is co-evolution of practice. So as things evolve, the practice change. So we used to have best architectural practice on compute as a product. So So one of the characteristics of compute as a product is something called high MTTR, high mean time to recovery. So what that means is it takes weeks or months to get a new machine. So we used to do lots of things like capacity planning, disaster recovery test, N+1, scaling up. Now, as compute evolved to a utility, then it took seconds to get a new machine. So mean time to recovery was low. So we can now distribute systems, design for failure, chaos engines. We could do continuous deployment. I mean, we could have done continuous deployment in the past, but you're waiting months for the machine to turn up. So it was sort of pretty pointless. We didn't have a label for this stuff. Andy and Patrick, two friends of mine, later on called it DevOps, but there was that change of practice. The next pattern you learn is that efficiency enables innovation. As the underlying components become more commodity-like, they enable new things to be created, new needs. And those new needs create, new things create new sources of value or systems of worth. The next pattern you learn is you have no choice over evolution. This is known as the Red Queen effect. So if you're up against others and they have access to new value, speed, and efficiency, it creates pressure on you to adapt. And the more adapt in your ecosystem, the more that pressure mounts until you have no choice. The last thing it's not the last, as I said, there's about 30 of these. We're only doing a handful. The next thing you learn is Jevons paradox. So as the underlying commodity component becomes a commodity, what you do, you get some effects which are due to if there's price elasticity. But what the really major impact is, which is what Jevons talked about, is that as people build new industries, these new higher order systems, as they evolve, as they become more popular, they massively increase the underlying demand for the thing that's become more of a commodity. So the example Jevons gives is in the coal question, which was back in 1865. They made steam engines more efficient, so people thought that would mean less coal. What it meant was more coal, because they made steam engines more efficient, because that now enabled new uses of steam engines. So it's always these new industries, things on top, which increases that underlying demand. So back in 2006, where would you invest? You would invest in like the cloud, the emerging practice, though it didn't have a name, the new needs. Where not to invest would be the best architectural practice based upon computers and product. Now, I ran strategy for a company called Canonical in 2008. We use these maps to attack the space. Canonical provides something called Ubuntu. We were 3% of the operating system market. We're up against Microsoft and Red Hat. They've got all the billions. They've got all the money. They've got all the engineers. But we went from 3% of the market to 70% of all cloud computing in 18 months. So basically, it's a bit like go back to the Battle of Thermopylae. We used the space as a force multiplier for ourselves. So we didn't have the engineers, we didn't have the capital, but we understood the landscape, so we knew where to attack. And that's how we went from 3% to 70% of all cloud. If you were involved in that time, you probably saw Ubuntu come from nowhere to dominate that space. Still pretty much dominates that space in terms of operating system. Simply you are Matt. Okay. So by 2010, the new emerging practice got a new name, DevOps. Andy and Patrick called that. The best architectural practice got a new name, Legacy, because it's best architectural practice for computers products. So it's going. By about 2014, I think it was, AWS came out with Lambda. So we saw the runtime heading towards more of a commodity utility. So that's serverless. Exactly the same patterns occurred. We got a new emerging practice, which later on got called FinOps. It takes always a bit of time to work out what the name is. So there was FinDev, FinOps, or whatever. And you get new things built on top. No different from the previous cycle. Where to invest in 2014? As soon as it appeared, you would start thinking about those spaces. New emerging practice, though we didn't call it FinOps until about 2018. Where not to invest? Well, that's now in these underlying spaces stuck behind inertia barriers. And that, of course, includes DevOps and cloud. By 2014, 2015, 2016, you're starting to think that this stuff is heading towards the new legacy. Of course, if you turned up to a DevOps conference and said that, it'd be burning heretic. It's a wonderful book on this stuff called Flywheel Effect by Dave Anderson. You'll find lots of maps, lots of explanation of this stuff in there. Then we get to stratagems, of which there's about 150. They're all context specific. There's a wonderful book again. It's called Reaching Cloud Velocity. It's produced by AWS. It's their second ever book themselves, about themselves. It has 17 pages of my mapping in there, including a particular model I created back in 2005 called the Innovate, Leverage, Commoditize model. It's very simple. You take a pre-existing activity, turn it into a utility, let everybody build on top, mine the metadata to spot future patterns, which you then commoditize to new component services. It's very powerful, very destructive, but you can read about it there. All right, let's talk about AI. So this is roughly where we were 2014, about that time. Let's just roll on to 2018. It's expanded out a little bit. I'm just going to get rid of a lot of this stuff because I don't want to talk about cloud and DevOps. So I'm just going to put serverless down the bottom. FinOps had by then had become much more sort of evolved. It had a name. Oh, we were just about the time we were giving it a name, like a coding environment application. Great. So one of the things we noted in 2018 was machine cognition. Those services were constantly evolving, and this argument came up that it was eventually some aspect of it was going to become more of a utility. And what would that do? Well, new practices, new needs, that's going to happen, but it wasn't very exciting. What was interesting was when we started combining it with some of the practices that were starting to emerge in this FinOps label. And so we started talking about the need for conversational programming environments. So this is an old idea. It goes back to the work of Nicholas Negroponte and Jonna Freeman. So the process of designing a system is a conversation between one or more designers. So the question then becomes, what if one of the designers is the machine? And so a good friend of mine, I ran this presentation it was 2017, 2018, around then, picked up on this, and then he decided to build this and presented at AWS reInvent. So this is a system called Jarvis that you had a conversation with. It's an AI system, and it would build you another system based upon the conversation that you had with it. So this was the sort of real start of conversational programming. By 2024, we had new labels for it. The machine cognition, we now knew it was large language models, large multimodal models, and the variations thereof. The practices, well, we're still fighting over what they're going to be called: copilots, prompt engineering, CHOP, vibe engineering. That's fairly normal. This is in that space of conversational programming, but that's now rapidly growing. A couple of things to note. Those practices are still in the emerging stage. I know people are writing various books and everything on this sort of stuff. Just say we're still learning about it. You don't have a choice over this stuff. Same as beforehand, it's the Red Queen effect. You've got the efficiency, you've got the speed, you've got the new sources of value. So that's going to create pressure on everybody to adopt. So we knew that was happening. Jevons paradox is an interesting one. So with the cloud, people sort of miss this. We used to get all these CIOs running around saying cloud means I can get rid of all my sysadmins. So because they were told they wouldn't need sysadmins. Well, it's true. I mean, your sysadmins would look after, you'd have a team looking after 2,000 servers. You think you go into cloud, you need less of them because they don't have to rack and mount something. They miss the Jevons paradox, and your average estate for a large corporation went from 2,000 to 200,000 servers, virtual servers. And so that's a massive scale improvement of the problem, or huge. It's orders of magnitude, two, in fact. So you actually needed just as many sysadmins, but they needed to have different capabilities. And what a lot of rather foolish companies did is they got rid of their sysadmins and then had to go and hire them back desperately as more expensive DevOps engineers. But at the time they were doing so, everybody else has made the same mistake. So prices just rocketed. You're going to see the same with software engineers. We're going to see an explosion of new activities, particularly as people turn up with vibe coding environments, because we're still going to have to do elements of review in terms of the code. So we're going to need software engineers to be using those AI systems just to keep up with the competitive state, the amount of work that needs to be done. But people will make the same mistake. They'll fire the wrong people and then try desperately to get them back again. It's happened pretty much every one of these sort of cycles all the way back. Well, these cycles have occurred all the way back to the Industrial Revolution, so it's been going on for some time. All right, let's talk about coding. So this is roughly where we are in 2024. A couple of things I want to point out. Our coding environments are changing to copilots. Okay, basically these are tools. So one is a tool I use to write code, and the other tool is more a conversational environment I use to write code. There's an interesting problem in software. So to explain the problem, I'll go to the physical world rather than the digital. So when I'm at home, I like making soups. And when I make a soup, I'll use a blender to blend the soup. If somebody asks me, why don't I build a deep mine shaft with a blender? I would go, well, that's a really daft idea. If I'm going to build a deep mine shaft, I'm going to use mining equipment. And if somebody said to me, oh, but you could use robots with blenders, again, that's a really daft idea. Now, in the physical engineering world, we build tools to the contextual problem that we have. So if I'm making soup or I'm building a deep mine shaft, very different problems, very different tools. In software, we don't do that. We try and use the same tools. I'm building an electronic healthcare record system or an online gambling site. I'm going to use the same development tools, the same development environment. Now, that makes almost no sense at all from an engineering perspective. And there's one exception to this, is tests. In tests, and tests are small tools. So they have an input-output, and they're very small tools. We build highly contextual tools. If you think about test-driven development, we build an entire suite of them to look at a problem. If somebody turned up and said, I've got the Acme list of 100,000 tests, you should apply them to your application, you'd look at them like, well, how's that going to work? I mean, the 100,000 tests, that's not even my problem. But we do this with other tools, which is something very bizarre, and we'll come back to that shortly. All right. We know the tool environment is changing. The languages are changing. Obviously, we're moving from deterministic code to non-deterministic, such as prompts. The other thing that's changing is the medium, the symbolic instructions. So we're moving from code as text to more code as images. Now, why does this matter? All right. On the right-hand side is a map of coherent city transport put together by a whole bunch of city planners back in October 2022. On the left-hand side is the code that makes that map. So there's a domain-specific language for mapping. That's what it's written in. Okay, when we talk about the map, we talk about objects and relationships and context. And when we talk about the text, we generally talk about rules and syntax and style. Now, this sort of conversation occurs in any engineering department. If you walk into an engineering department, you see the same problem discussed in different ways. One is on the screen, where we talk about rules and syntax and style, and one is on the whiteboard, where we talk about objects, relationships, and context. Same problem, two very, very different conversations are occurring. And so one of the interesting things of this change of symbolic instructions is it changes the nature of the conversation. Now, as I said, you see this in engineering departments. We have one conversation on the whiteboard and one on the screen. And people often think, well, AI is just going to replace the coder. So we're still going to draw the diagrams, and we're just going to give it to an AI and it will generate for them. So we make the decisions and it will generate the code. The problem with that is architectures don't look like this. This is a diagram of what we want an architecture to look like. But when you actually look at architectures, they look like this. This is like the functions between different objects within a system, a relatively simple system. And what this means is the code is the architecture. The diagram we draw is just a statement of belief. It's what we wish. It's our intent. We'd like it to be like this, but it doesn't look like this. The code is actually the architecture, and actually the real architect and decision maker is the person writing the code. You can express, wishes, intent, beliefs, which is what we do with architectural diagrams. But somebody makes real decisions from those, and they make the real choices, and that's in the code. Why does this matter? Well, it means the real decisions are made in coding. And so when we talk about things like vibe coding, so there's two different forms. There's AI plus software engineering, so we get an AI to write some code and we get somebody to review it. And there's vibe coding, which I've only done about 500 hours worth, but we get basically the system to build it without ever reviewing the code. It's a really interesting experience, by the way. But when we are using vibe coding, the AI is making the decisions for us. All our architectural diagrams are simply intents and beliefs. So one of the big and huge architectural questions of today is, how much do you value a human to be involved in the decision-making process? And the simple way of thinking about this is, if I go back to a map, I'm going to look at the map. There's going to be some bits I'm going to outsource. I don't really care. Some bits which I'm going to say, okay, we're going to use vibe coding over here. We're going to use the AI to build it. We're going to build a whole bunch of prototypes. It's not that important to us. And then some bits in the middle where we're going to say, okay, we might get the AI to write some code. We need to do that, but we're going to need to review the actual code it produces. And where and how these borders change, a lot of that will depend on things like trust, which are relationships which take time. There's all sorts of things you can do in terms of getting agents to build code, agents to test. There's all sorts of gotchas and horror stories in there. It takes time to build trust with these systems. That's a social system. And I'm afraid we're not going to be vibe coding nuclear power safety systems anytime soon. I know I get to hear these wonderful VCs who have invested so much money in this space, trying to say we don't need software engineers anymore. They're all going to be gone by the end of the year. There will be changes, but it's going to take a lot longer than that. All right, so now I want to talk about decisions. The process of making a decision about a system. The first thing I need to do whenever I make a decision, it's some sort of assessment or choice. There's no decision if I've only got one option. That assessment depends upon exploration of the system. So that which depends upon a conversation, either with a person who built something or the system itself. That conversation depends upon information. That information has to be synthesized somehow. And that depends upon some sort of development experience interacting with the system. All right. I said tests are small tools. And there was something interesting in the way that with test-driven development, we take lots of small tools and build a test suite for an entire application. So I want to go through that. When we're using test-driven development, we start with a hypothesis approach. So we have this idea that the application doesn't have this new feature we want. So we write a test and to check whether this application has the new feature we want. Of course, hopefully it fails, so we have to go and code it. So we start off with a hypothesis. And our exploration is systematic. So we use small tests to explore the problem space. And our conversation is through a model. That test suite is a model of what we're trying to create. So we often talk about the best specification is the test suite. That information is generated. So when we run tests, we have the traffic lights, red, yellow, green, for example, and that's generated from specific coding. And our development experience is composable microtests. So lots and lots of small tests, small tools. Then we code it. So when we code it, our development experience is generally we go and use monoliths, our big favorite sort of coding environments. Those coding environments, we generally do inspection. So we go and read a bucket load of code. So we've got a problem with a 30 million line of code legacy system. We go, oh, we better read 30 million lines of code or something ridiculous. So our process of gathering information is fairly manual. We read code, we try and identify the problem, maybe go and get some log files, maybe go and get some architectural diagrams as well, because we want to have a data-centric conversation. But most of that stuff is belief-based. The architectural diagrams don't represent reality. They're just what we intended, not what it actually is. So our exploration tends to be fairly ad hoc. It depends upon the person, where they're exploring, and ultimately it's gut feel driven. It's based upon the experience of the person and what they think the problem is. So what's interesting about this is that's a craft. Software development is very much a craft. But software testing is very much an engineering subject. So when we talk about software engineering, there's only one bit which is engineering, and that's testing. The rest of it's a craft. So the real engineering is in testing and not coding currently today. And the real decisions are actually made in coding, which is an interesting problem to have. So we make the decisions in the bit that's the craft, not the bit that's the engineering. So if you want to change coding and make it more like engineering, how do we shift it from over there to over here? It's really trivial, actually. We just have to break these monoliths and use composable micro tools. So we need to get into the habit of building tools for the environment we're actually looking at. So an example of this, I have one particular project. It's a legacy migration project. They'd spent many person years trying to do this legacy migration, about 20 to 30 person years, failed miserably. Friends of mine I work with, a group called Fenk, they asked them to come and have a look at the problem. And I mean, it's a $16 billion market cap company, this core legacy system, right at the heart, dead language, as in the developers are dead, the people who wrote the language are dead, nobody actually knows how it operates, they're all terrified. So they gave them the code, they went away, they had a meeting 4 weeks later. The CIO of this company had made a bet they'd fail after a year. So they have this meeting, they say, how are you doing? They say, we're done. And the reason why they were able to do it is they spent the first 3 weeks building the tool to solve the problem, then they solved the problem. So it's a bit like we'll spend the first 3 weeks building a mining equipment, and then we'll go and build a deep shaft mine, rather than try to jump in there with a whole bunch of kitchen blenders and which is what we normally do. So if we want to change things, I'm afraid we're going to have to shift to much more contextual tools. Of course, we're going to have to get away from trying to use kitchen blenders everywhere to building contextual tools. So the problem is the kitchen blender vendors or software tool vendors are all trying to convince us that the future is have your kitchen blender with a bit of chat GPT or AI. If we want to change, that's the bit we have to change. Of course, that's not going to go down well with software vendors, multiple billion-dollar industry, trying to convince you that building software tools is hard. It's not actually, but there we are. So I started with the origin, how I got into the subject. We talked about maps, what the difference between a map and a graph is. Then we talked about the different types of patterns. You've got climatic patterns, you've got doctrine, you've got contextual forms of gameplay, of stratagems. So we went through a couple of examples of doctrine, focus on users, understand your user needs, understand the supply chain, how evolved the components are. Most organizations are pretty poor at this stuff. And then we went on to sort of like multiple methods, where to use like Agile, extreme programming versus Six Sigma, how you combine them together in a single system. Then we talked about these patterns for change. So that's the climatic patterns, how we anticipated, for example, the shift in cloud, how we use that to work out where to invest, where to focus. Then we went through serverless and then onto the AI space. Now, the AI space is really interesting because not so much about the technology, industrializing large language models. Okay, that's cool, I suppose. What's really interesting, the change of practice, how it impacts tool sets. I mean, and the knock-on impact in terms of where we value humans in this decision-making process in terms of where we architect. But that also leads us to a problem with software engineering, in the fact that most software engineering, so the major part development, is not actually engineering, it's a craft. The only real engineering bit is testing. And if we want to make development more like testing, we should learn more from testing. We really need to look at the tool sets that we're actually using. Lessons to take home. Number one, observe your landscape. Really important to understand the environment before you make a decision. Realize that one of the big architectural questions you're going to have to be facing is, where does human decision making matter? In order to do this, you really need to have it's easier to do it if you've got a map of the landscape, because it's easy for me to say, outsource this, where we are, software engineering and AI, that stuff over there, prototypes, we vibe code. The major part of software engineering, as in development, isn't actually a craft, not an engineering practice. In order to change that, we're going to have to change these monolithic tools. That's me. I got to the end. We didn't get on to sovereignty. That's a different subject altogether. I can. We've only got a few minutes. I would have to massively overrun. I'd have to overrun by about 5-10 minutes. I don't mind if I do. It's evening for me here, but I know many of you have got to go. I hope you found that useful.
That was great. We do have Simon G had a question here that might be a good use of our remaining 3. He's asking, how did you come to the conclusion of breaking monolith to composable micro tools is the way to bring back engineering versus craft?
Well, there's nothing wrong. Well, software development is a craft where it is at the moment. And part of the problem is that we are trapped in this world. We have these very monolithic tools which we are constantly trying to adapt to different problems, rather than building tools for the space that we're looking at, except for in one area. Testing. And how did I come to this conclusion? It was that looking at test-driven development and realizing that tests are small tools. And what we don't do is we don't try and use the same test everywhere. We build tests for our problem. So I'd come across a toolkit called Glamorous Toolkit. I met a friend of mine is a chap called Tudor Gerber, who runs Fenk, and they provide something called Glamorous Toolkit. And it was fascinating. I used to go mad with this stuff. I'd see this group of people working at speeds I just couldn't believe. And what you've got is they'd have like 12 people. But between them, they'd be using something like 8,000 tools, small tools, combined, like small tests, combined into an overall tool set to solve a problem. And I'd look at organization that have like 8,000 people and 12 tools. And they're struggling to cope with it. And these people are just like tearing through this stuff. And I just couldn't get my head around it. And what was interesting was the fact that the environment has all these tools in, all these small components of tools, and they're all highly contextual. So when you're looking at a problem, they actually gravitate towards you. And I just couldn't work this out. It just seemed so bizarre. And then I realized this is exactly what we're doing with testing. So with testing, we don't have standard suites. We build up a suite for the context, like we build a tool, because tests are small tools. We basically build the overall test suite, the overall tool for the context that we're looking at, the problem that we're trying to solve. And if there are highly defined problems which we have everywhere, then sure enough, we'll have very, very standard tests, which we can reuse over and over again. But most software problems are not highly defined everywhere. They are highly contextual. There may be components which are highly defined. And so just bringing that approach from testing into tools is what I think we need to do. I think that's the biggest bottleneck and the biggest problem. And there's another realization in this, is just chatting with people, is when you ask people how much time do they spend reading code, you grab a bunch of engineers and just ask them, how much time do you spend reading code? Most people say about 50% of their time is spending reading code. Okay. Now ask them, when's the last time you've talked about how to optimize the process of reading code. That discussion has almost never happened. So 50% of our entire development budget is spent on doing an activity which we never discuss, and we never talk about how to optimize. I mean, anything else, you'd be like, what the hell are we doing? So that's this bit here. I'm actually writing a book on this with Tudor, which is called Rewilding Software Engineering, because I think tool vendors, bless them, I think there's certain discrete problems they're great for, but I think they've caused us a lot of problems.
Awesome. So
hopefully that answers your question.
So that's great, and it brings up a kind of another kind of question around that. How much of the small tool, like the tools you see valuable, is it because they either can be composed or modified in the ways the developer's needs, rather than we've got 12 really big tools that just work one way and we can't change anything about them?
Well, so it's amazing. So I started using things like Glamorous Toolkit, and and the first thing you realize is when I'm normally in a development environment, I hit these artificial boundaries. There's only so far I can dig into something, and then there's I just can't go any further. You can open up any tool and you start exploring code, and I want to know where this goes, and there's barriers all over the place which limit, so I have to jump out and find another tool to go and explore that. So I'm constantly context switching rather than my tool being, we talk about integrated development environments, and they're completely unintegrating. I'm jumping between different tools rather than having all these micro tools in a combined environment. It's a bit like having my test suite, thousands of tools in, thousands of tests in my test suite working in harmony together. So once you start going down this process, you start discovering incredible. You start looking back at old development environments and start going, "Oh my God, how did I live in this environment?" But you did, because I didn't know better. Because I used to believe that building tools was hard as well. But if you go back to the early days of testing, the idea of, we're going to build loads of small tests for our problem, people were like, oh, that sounds really daft. Why would you do that? Oh, we're going to build a test suite at night. Oh, God, what? That sounds like testing is what you do after you've written the code. You write the code, you hand it to some people and say, go test it. Well, it took ages to get people to change that attitude as well.
Right. Well, that's great. Well, Ian posted the link to Glamorous Toolkit, and I just brought it up, and I see some very interesting things. So that's what I'll probably be doing the rest of this afternoon, is digging into that. So, Simon, thank you so much for coming. This has been very, very enlightening. Really appreciate you taking the time.
It's
fascinating talk related to the subject and the talk beforehand when we were just getting stuff set up. So, thank you so much. Really appreciate it. And thank you for time. Thank you so much.
It's a pleasure. Thank you.
And have a great rest of your afternoon.
Thank you. Stop sharing.
Thank you. That was great.